Hi everybody, let's talk about how we solve polynomial equations. So the directions on this problem say solve the following polynomial equation, and it's given in its equation that is equal to 0. That's pretty crucial as you want it equal to 0 before you can even start. So what we're trying to find is we're trying to find solutions to this equation. Now when we talk about solutions, what we're really talking about is we're talking about zeros or x-intercepts. So x-intercepts, zeros, solutions, all the same thing there, okay? So we're trying to find solutions to this problem. There are some clues here that kind of tell you how many solutions we're supposed to get. When you look at the polynomial equation, look for the degree of this polynomial. The degree being the highest power, which is 3. So when we have a degree of 3, what that tells me is I'm supposed to have 3 solutions. So until I get all 3, I know that there is more to be found. So easiest way to start this problem off is we're equal to 0. What I'm going to do is I'm going to take this equation and I'm going to plug it into y equals and then graph it on a calculator. So I already have it plugged in for me and I hit graph. There we go. A quick and easy way you could solve pretty much any equation is if it's equal to 0, you just look for x-intercepts. X-intercepts is the same as zeros, which is the same as solutions here. So we actually cross the x-axis at -3. And if you're not sure, you can look at the table. And when you go to -3 in the table, you're going to have a y value of 0. So one of my solutions is -3. Now remember, I said there were supposed to be 3 total solutions. Right now I just have 1, so I'm missing 2 more. So here's how this problem can progress from here. One thing that's a pretty key feature here is when you have solutions or zeros, they could be tied to factors. So the factor there would be x plus 3, because if you set this equal to 0 and solve, you get -3. Now, if I take my original polynomial and divide by one of my factors, one of my known factors, I can kind of break this problem down using division, which is essentially as factoring. So what should happen is, if this is truly a factor of this polynomial, if I take my original polynomial and divide by x plus 3, if I get a remainder of 0, that confirms that this is a solution, okay? If I don't get a remainder of 0, it is not a solution, but we kind of already know it's supposed to be. So I have options. I'm going to take this original polynomial and I'm going to divide here. Now I'm going to choose to use synthetic division because it's quicker and quite a bit easier than long division, which means I'm going to put a -3 in the box, pull all the coefficients here. So we got 1, 3, 25, and 75. So if we go through this synthetic division, I should get a remainder of 0. That shows that this is a factor and that -3 in fact is a solution. So adding down, multiply by the box to go up, add down, multiply by the box to go up, add down, multiply by the box to go up, add down. So we got the remainder of 0, which is exactly what we were looking for. So let's take this and flip it back to a polynomial. Remainder of 0, good. 25 is my constant. This would be my x term, but since it's 0, don't need to write it. And this 1 would be my x squared term. So I'm left with x squared plus 25. Now, I started with a polynomial with the highest power being x to the third. I'm now down to a quadratic x squared. We got options here on how we could solve this, okay? When we looked at solving quadratics, our options were we could solve by graphing, factoring, using square roots, complete the square, and then our final option was the quadratic formula. Now, with what kind of we're doing with these problems, I'm going to tell you already that solving by graphing isn't going to really be useful, because we started this problem by solving by graphing, that you're not going to see anything new if you tried to graph this. So solving by graphing, yes, it is a way to solve quadratics, not really going to work here since we graphed earlier. We could try and factor here, not always going to work. Square roots is always an option whenever you just have an x squared term. If you have an x squared and an x term, can't really use the square roots route. But when it's only an x squared like this one, we should use that, okay? I'll do the square roots here in a second, but you could also try and complete the square, and then I would kind of leave the quadratic formula as, hey, nothing else has worked, so that's my last option. Primarily, most kids are going to use either factoring, square roots, or quadratic formula, and I would try those in those order. So this one is kind of yelling at you, hey, you should use square roots because you have an x squared term and no x term. So in order to solve this using square roots, all we want to do is just try and get x by itself. So that means we got to move the 2 and the 25 away from the x. So I'm going to start by subtracting the 25 over. What this would do for us is you would have x squared equals 25. Now to get rid of a square, we're going to use square roots, hence solving by square roots. On the left side, we get an x. On the right side, we're dealing with a square root of negative 25. Now, a little bit of a callback to a previous section. Anytime you're taking a square root of a negative number, you could take the negative away from the number. So we could break that down to a negative 1 and a 25. If you do the square root of a negative 1, you're going to get I. If you do the square root of 25, you're going to get plus or minus 5. So what we just found here is 2 more solutions, one of them being positive 5i and one of them being negative 5i. So if I add that to my list, plus or minus 5i, I now have negative 3, positive 5i, and a negative 5i for 3 total solutions. Now if you remember at the beginning of this problem, we talked about the degree being 3, so that means there should be 3 solutions. There they all are. Okay, I'm going to do one more problem with solving polynomial equations, a little bit more complex. So we're going to start off with x to the 4th plus 8x to the 3rd plus 14x squared minus 11x minus 12. Again, you want to start off by taking that equation, carefully plugging it into y equals, and we're going to start by trying to solve this by graphing. So when I graph this equation, that's what the graph looks like. Anytime you have an x-intercept, that is a solution. Now this one's pretty tough to see, so I'm going to use the help of the table here. What I'm looking for is there any x value that has a y value of 0? So I'm looking for solutions, x-intercepts. So I'm looking for any time y is 0. So if I look through here, negative 4 is one spot. And then if you scroll down at x equals 1, it's another spot. So negative 4 and 1. And I can look around. It doesn't look like I have any other cases of y being 0. So I only have 2 solutions right now. If we look at the original polynomial, the degree is 4. So I'm supposed to have 4 total solutions. So I'm halfway there. What I'm going to do, just like last time, I have solutions to start with. Start by dividing here. Okay, so if you have negative 4, that's an x plus 4 as a factor. Divide the original polynomial by x plus 4. Again, you could choose long division or synthetic division. I pretty much always go with synthetic division. It's quicker, faster. So negative 4 in the box. Coefficients of 1, 8, 14, negative 11, negative 12. And we should see a remainder of 0. So adding down, multiply up. Add down, multiply up, add down, multiply up, add down, multiply up, add down. So my first time through with negative 4, I get a remainder of 0. So that means, yes, x plus 4 is a factor here, and I have a 0 at negative 4. Now, we could flip this back to a polynomial, so that's negative 3 is our constant, negative 2 is negative 2x, 4x squared, and x to the 3rd. So that's what we're working with now. We went from an x to the 4th down to an x to the 3rd as our highest term. You could set this equal to 0 and solve, but it's pretty tough to work with. We're working with a cubic here. Instead, I would like to work with a quadratic. So here's what you could do. Keep doing the division, okay? Do division as many times as you have solutions to work with. So I use negative 4. Why not use 1? So I'm essentially going to pick up where I left off from last time with this 1, 4, negative 2, negative 3. Do synthetic division again, but this time start with a 1 in the box. So 1, 4, negative 2, negative 3. And here we go. Add down, multiply up, add down, multiply up, add down, multiply up, and we get a remainder of 0 again. So that tells you, hey, this 1, or x minus 1, is also a factor there because we got a remainder of 0. So let's take this last piece that I got here and flip this to a polynomial. Remainder of 0, constant of 3, 5x, and an x squared term. So we're looking at x squared plus 5x plus 3, which is a quadratic, that I'm going to try and solve using one of our methods we talked about on the previous page. So you could try and factor this. Good luck. You're not going to be able to. You're not going to be able to find two numbers that multiply to 3 and add to 5. We can't do square roots here because there's a presence of an x term. You could try putting the square there. Pretty tough. You're going to run into fractions. So I'm kind of running out of options that I'm going to do the quadratic formula. So I'm going to write down my a term is 1, b is 5, c is 3. So plugging into the quadratic formula, we're talking x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Now we've talked about the quadratic formula before. I would start by trying to simplify what's inside that square root there. So I'd figure out what 5 squared minus 4 times 1 times 3 is. And if you do that in a calculator, you're going to get 13. So we have a negative 5 plus or minus the square root of 13 divided by 2 times 1, which is 2. Next thing I'll try and do is break down the square root of 13. Not going to be able to get really anywhere with that, and that's okay. But if you had like square roots of like negative 9 or some other type of square root there that you can't break down, you'd want to do that. Can't do anything there. Then I would check and see, can I divide things by 2? I can't do negative 5 divided by 2 and can't really divide the square root of 13 divided by 2. So believe it or not, we're stuck right there. And that is the solution to solving that quadratic. So let's add this to the list. We need a negative 5 plus or minus the square root of 13 over 2. Negative 5 plus or minus square root of 13 over 2. Now, we had talked about I should have 4 total solutions. There's actually 4 here. One solution is negative 4. One solution is 1. Now, this is a little bit tricky. There's a plus or minus there. So one of my solutions is negative 5 plus the square root of 13 divided by 2. And my final solution is negative 5 minus the square root of 13 over 2. So there's 2 solutions here, plus these other 2 makes 4 total. And that is a crash course on solving polynomial equations.